everyone. I'm Asmita, the head of Sahaay.
In Project Gesturize, we're trying to convert sign language into speech in real time. We're trying to tackle that issue as well by developing machine learning models to take in such keywords and generate coherent sentences.
And after that, we moved on to another model which includes cheap electronics.
If you wanted to ask one, how are you? That would come out as you, how.
Hello everyone. I'm Asmita, the head of Sahaay, the social innovation club of IIT Madras. So we are a team of individuals who aim to leverage the usage of technology to solve socially relevant problems, be it AI, ML, electronics, or mechanical designing. Any technology that helps solve potential social issues is what drives us to work our best. So everyone in the team are passionate about two things. One is obviously the usage of technology. The other one, which sets our club apart, is the motto to leverage this technology for any kind of socially relevant purpose. So let's look at one of our projects, Gesturize, which aims to translate sign language into speech in real time.
Hi, I'm Keshav and this is Nitin. We're both members of Project Gesturize, a project under Sahaay. In Project Gesturize, we're trying to convert sign language into speech in real time. Current models that exist to do this are lacking in some fundamental aspects. Most models work with static gestures that don't involve motion. But then the majority of sign language gestures in Indian Sign Language at least involves motion, so that increases the complexity of the problem. Indian Sign Language also tends to focus on keywords as output. So when a user is trying to say something, they would give you the keywords in the sentence, and it is up to the receiver to understand what the user is trying to say. We're trying to tackle that issue as well by developing machine learning models to take in such keywords and generate coherent sentences that any layman could understand.
Coming to the technicalities, we started off with an OpenCV model in which we would input a camera recording input, and it will be tracking the hand landmarks by its own, and we'll process the output and find which gesture is being performed. And after that, we moved on to another model which includes cheap electronics, in which we are using flex sensors, which would be giving the data about how the fingers are moving, and also the electronics include a few parts like ESP32 and an MPU, which will give the relative hand coordinates, and it will be processed by the ML model to find which gestures is being performed.
One of the issues we're trying to tackle is that Indian Sign Language is very poorly documented. There are no large-scale, high-quality data sets that you could use to train machine learning models on this. We've crowdsourced a data set from within the institute with the help of NSS. So we'll be public open sourcing that in some time. We're also aiming to make these models as less resource intensive as possible. We don't want to be using huge deep learning models that require very high-end GPUs or compute power in general to run. We want to make this product available on any cheap edge device so that anyone could be able to use it. So in sign language, if you're going to ask, a very basic example would be if you wanted to ask one, how are you? That would come out as you, how. Our model will try to convert that into how are you so anyone would be able to understand it. Dynamic gesture models do exist. But then typically they would focus on a very limited set of vocabulary. We're trying to scale this up and make it work for larger data sets.